All right, guys. So here's our video on magnetism. A magnet is any material that attracts iron or materials containing iron. Magnets have two poles. These are the three things we're going to talk about. Magnets have two poles. Magnets exert forces on each other, and magnets are surrounded by magnetic fields. All right, so each end of the magnet is called a magnetic pole. One part of the magnet always points north. That is called the north pole. One is always pointed south. That is called the south pole. Okay. Usually you'll see them also written as the north being the positive, the south being the negative. So if you break a magnet in half, you'll gain essentially two new magnets. So here's one magnet. The north portion got a south portion. The south portion got a north portion. And we end up with two magnets still magnetized. So they exert forces. So magnets exert forces on each other. Forces can either be a push or a pull. If the magnets are of like poles, they will repel each other or push. If they are opposite of each other, they will pull or attract. So nothing to write, just to look. So here you can see north-south, they're pulling on each other. North-north, they're pushing away. The shape of a magnetic field can be seen if we can draw lines. So we draw the lines from the north pole to the south pole. The lines show the strength and the direction of the magnetic field. The closer the lines are together, the stronger the field. The lines around the magnet are closer together at the pole because they're where the force is strongest. So here and here you see that their lines are close together relatively. Here they're relatively far apart. So you got a weak magnetic field and a strong magnetic field. So opposites attract, where you can see we have the north and the south. So they're pulling each other together very hard. Here there's a weak pull because they can't possibly touch each other, but there's still a field around them. So the likes repel. So you have two north facing magnets. You can see the lines repelling each other stronger here, but even repelling out here as well. Okay, so the earth behaves like a big magnet. There's a lot of iron in the earth, in the mantle and in the core. So it actually ends up acting like an earth. Now, the reason our compasses point north is because the way the earth's oriented, the south pole is up the magnetic south pole is up top. So that's why our compasses point towards the north. And like we said, they're surrounded by a magnetic field, strong here, weak on the outside. This is iron filings with a magnet, and you can actually see a real-world example of a magnetic field. So here we have a piece of magnetized and unmagnetized steel. The unmagnetized steel, as you can see, is kind of chaotic. Nothing's really aligned. It's all kind of over the place. On the bottom, you can see we're very aligned, very organized. So this piece would be a magnet. We would be able to pick it up with a magnet. This piece would not be able to be picked up with a magnet. All right, that's it. That's just a short, brief little intro into magnets. And that'll be all.